In our solar system, there is a planet that humanity has visited only once, not because we do not want to go there again, but because we can almost not do it. It is simply too far away from us. Even flying at a speed of 54,000 kilometers per hour, it would still take 13 years to reach it. The last time we approached it was in 1989, and the reason that mission was possible was because it used a rare cosmic planetary alignment. This alignment occurs only about once every 175 years. The next time will not happen until 2153. This planet is Neptune, the outermost planet in the solar system. Over the past 35 years, we have only been able to observe it from across 4.5 billion kilometers of deep space through telescopes. And the latest discoveries from the James Webb Space Telescope are completely overturning our understanding of it. Even the deep, brilliant, dark blue gemstone-like planet image shown in textbooks for decades is wrong. The time goes back to the year 1846, Paris, France. If you looked up at the night sky at that time, you could see 5 planets with the naked eye. By the 19th century, astronomers had added a 6th planet, Uranus, which was discovered in 1781. But a problem soon appeared. The orbit of Uranus did not match theoretical predictions. At this moment, a French mathematician appeared. He was Urbain Jean-Joseph Leverrier. He was obsessed with studying planetary motion. Leverrier carefully calculated the orbit of Uranus, but discovered that it did not match the predictions of Newton's theory of gravity. Sometimes Uranus accelerated, sometimes it slowed down, and its behavior was abnormal. Leverrier reached a bold conclusion. Beyond Uranus, there must be another planet that had not yet been discovered, and it was this planet whose gravity disturbed the orbit of Uranus. So he did something astonishing. He picked up paper and pen, and relying only on mathematical calculations, calculated the exact position of this unknown planet in the sky. After that, he sent the calculated results to the German astronomer Johann Gottfried Galle, and the letter contained precise observation coordinates. That very night, Galle pointed his telescope at that position. In just 1 hour, he found the planet. It was less than 1 degree away from the position predicted by Leverrier, and that planet was Neptune. It was not accidentally scanned by a telescope. It was not found by searching the entire sky. It is the only planet in human history that was first calculated by mathematics and later observed with a telescope. And only 17 days later, humanity discovered its largest moon, Triton. This meant that we had not only discovered a new planet, but had also glimpsed an entire distant planetary system. But in order to truly see it clearly, humanity spent a full 143 years. Neptune is exactly 30 astronomical units away from the Sun, which is about 4.5 billion kilometers. If you stood on Neptune and looked at the Sun, its size would be only 1/30th of what we see from Earth. The sunlight it receives is only 1,000th of what Earth receives. Because it is so far from the Sun, Neptune needs a full 165 Earth years to complete one orbit around the Sun. From its discovery in 1846 until 2011, it finally completed the first full orbit since being discovered by humans, returning to the position calculated by Leverrier. Such an enormous distance made Neptune extremely difficult to study. Even the most powerful telescopes could only see it as a blurry blue dot. In the late 1970s, NASA discovered an extremely rare opportunity. Jupiter, Saturn, Uranus, and Neptune in the outer solar system were about to align in a rare configuration that occurs once every 175 years. A spacecraft could use their gravity to accelerate through gravitational slingshots and visit each of the outer planets in sequence. It was a once-in-a-century express route through the solar system. So on August 20th, 1977, NASA launched Voyager 2, beginning the greatest grand tour of the outer solar system in human history. In 1979, it arrived at Jupiter. In 1981, it arrived at Saturn. In 1986, it arrived at Uranus. And Neptune was the final destination of this journey. Even traveling at 54,000 kilometers per hour, Voyager 2 still took 3 full years to fly from Uranus to Neptune. On August 25th, 1989, Neptune finally appeared before humanity. For the first time in human history, we saw this distant planet clearly. Its rotating clouds, its enormous storms, and its iconic blue color. Voyager 2 flew past about 5,000 kilometers above Neptune's North Pole. In just a few hours, humanity obtained the opportunity to observe this mysterious planet at close range. Afterward, it continued flying into deep space, forever leaving the planetary region. Today, Voyager 2 has already entered interstellar space and is more than 20 billion kilometers away from Earth. From 1989 until today, no spacecraft has ever visited. Methane strongly absorbs infrared light, making it appear ghostly white, mixed with dark atmospheric bands, completely different from what we imagined. This is the real Neptune. It is not the intense, dark blue giant planet we once imagined, but a world with softer and more restrained colors. But do not be fooled by its gentle appearance. Inside this planet lies the most violent side of the entire solar system. From a distance, Neptune seems calm and peaceful, but in reality, it is the most extreme storm paradise in the solar system. During the Voyager 2 flyby in 1989, it captured a massive storm that shocked the scientific community, the Great Dark Spot. This storm was almost the size of Earth, violently churning in Neptune's southern hemisphere, and the wind speeds around the storm reached 2,100 kilometers per hour. What does that mean? It is the fastest wind speed ever recorded in the solar system, 1.7 times faster than the speed of sound, and 20 times faster than the strongest hurricanes on Earth. Even more astonishing is that Neptune receives only 1,000th of the sunlight that Earth receives. Logically, it should be a cold and silent frozen world. But reality is the complete opposite. It has the most violent weather system in the entire solar system. Just like Jupiter's Great Red Spot, Neptune's Great Dark Spot is also a giant storm rotating counterclockwise. But the two are very different. Jupiter's Great Red Spot has lasted for centuries, but Neptune's Great Dark Spot disappeared only 5 years after Voyager 2 photographed it. In 1994, when the Hubble Space Telescope observed Neptune again, the storm the size of Earth had completely disappeared. Since then, Hubble has recorded countless dark spot storms. They constantly appear and disappear. Usually a new group forms every 4 to 6 years. The longest lasted only 6 years. Most dissipate within 2 years. Even more incredible, in 2020, a storm that had been drifting toward the equator and was about to dissipate suddenly changed direction. It moved north again and escaped the fate of disappearing. Even today, scientists cannot fully explain the source of its energy. Not only storms. From 2019 to 2022, scientists discovered that Neptune's clouds were disappearing on a massive scale. Within just 3 years, almost all the clouds disappeared, leaving only a small patch near the South Pole. Even more surprising, this change is highly correlated with the Sun's 11-year activity cycle. Even from a distance of 4.5 billion kilometers, the Sun can still influence the weather of this distant planet. At this point, you might ask, Neptune and Uranus are clearly twin planets. Their size, composition, and distance from the Sun are very similar. Why is the maximum wind speed on Uranus only about 900 kilometers per hour, while Neptune is so violent? The answer may lie inside them. Neptune releases 2.6 times more heat than the energy it receives from the Sun. This constant internal heat drives the extremely fast storms in its atmosphere. Uranus, on the other hand, releases almost no additional internal heat. The mainstream theory suggests that billions of years ago, Uranus experienced a catastrophic giant impact. That collision removed most of its original internal heat. Since then, it became cold and quiet. Neptune, however, preserved the ancient heat from its birth. This heat may come not only from leftover heat during planetary formation, but also from diamond rain occurring inside it. At Neptune's center, there is a rocky core roughly the size of Earth. The temperature there may reach 5,000 degrees Celsius. Surrounding this core is what scientists call the icy mantle. But this ice is completely different from the ice we know. At the boundary between the core and the mantle, the pressure reaches 7 million times the atmospheric pressure on Earth's surface. Under such extreme pressure and temperature, water, methane, and ammonia are torn apart. They enter exotic states that do not exist naturally on Earth, such as superionic ice. In this state, the molecular structure breaks apart. Oxygen atoms become locked in crystal structures. Meanwhile, hydrogen atoms move freely like a liquid. The result is a strange material somewhere between solid and liquid. Even more astonishing things happen next. Carbon atoms inside methane molecules are stripped away under these extreme conditions. They crystallize and form real diamonds. These diamonds may fall like hail from the upper mantle toward the core. Scientists even speculate that deep inside Neptune, there may be an ocean of liquid carbon. Inside it float enormous solid diamond chunks. In 2017, scientists at the SLAC National Accelerator Laboratory in the United States simulated Neptune's interior environment. Using the world's most powerful X-ray laser, they bombarded materials. They directly observed nanometer-scale diamonds forming, perfectly confirming the theory. Right now, 4.5 billion kilometers away inside Neptune, Thousands of tons of diamonds may be constantly forming and falling. As these diamonds sink toward the core, they release enormous gravitational energy. That energy is converted into heat. In other words, Neptune may be heating itself through diamond rain. This extreme internal structure also creates another mystery that has puzzled scientists for decades: Neptune's strange magnetic field and its unexpected auroras. Neptune's magnetic field is tilted by 47 degrees relative to its rotation axis. When scientists first observed this phenomenon on Uranus, they thought it was caused by Uranus rotating on its side. But Neptune does not have such an extreme axial tilt, yet it has the same unusual magnetic offset. Eventually, scientists discovered that Neptune's magnetic field is not generated in the core like Earth's. Instead, it is generated by electrical currents flowing in the mantle. This dynamo effect occurs in the outer regions of the planet. Naturally, it cannot align with the rotation axis. This strange magnetic field directly creates Neptune's unique auroras. Jupiter, Saturn, and Uranus all have auroras. Earth also has beautiful northern and southern lights. But for 36 years, scientists could not find clear evidence of auroras on Neptune. It was not until 2023 that the James Webb Space Telescope clearly captured Neptune's auroras for the first time. But they look completely different from Earth's auroras. On Earth, auroras appear around the north and south poles. But Neptune's auroras appear scattered across mid-latitude regions where auroras should not normally appear. The reason is the 47-degree tilted magnetic field. Auroras form along magnetic field lines, so they appear far away from the rotational poles. The James Webb Telescope also detected trihydrogen ions in the auroral regions. These ions can only form during auroral activity. This discovery filled the final missing piece of aurora observations across the planets of the solar system. Even more puzzling is that since Voyager 2 measured Neptune in 1989, the temperature of Neptune's upper atmosphere has dropped by several hundred degrees. Lower temperatures make auroras dimmer. This is why for decades we were unable to observe Neptune's auroras clearly. Besides the planet itself, Neptune's moon system also contains some of the most unusual phenomena in the solar system. Neptune has only 16 moons, but the combined mass of the other 15 moons is less than 0.5% of the entire system. The remaining 99.5% of the mass is concentrated in one moon, Triton. This moon breaks almost every rule of the solar system. Almost all large moons in the solar system orbit in the same direction as their planet's rotation. But Triton moves in a retrograde orbit. It orbits Neptune clockwise, while Neptune rotates counterclockwise. Triton is not a native moon of Neptune at all. It is actually a dwarf planet from the Kuiper Belt. It formed in the same region as Pluto and has a very similar composition. Billions of years ago, it was captured by Neptune's gravity and became its largest moon. When it was first captured, its orbit was extremely elliptical. Neptune's gravity repeatedly stretched and squeezed it. This tidal heating melted its entire interior. Even today, Triton remains one of the most unusual worlds in the solar system. Its surface is less than 100 million years old. It is one of the youngest surfaces in the solar system. Voyager 2 observed only 179 impact craters on its surface. This means its surface is constantly being renewed by cryovolcanic activity. Voyager 2 also observed geysers erupting from its surface up to 8 kilometers high. These plumes eject nitrogen gas and dark material into space. Some eruptions can even last an entire year. Triton also has a unique terrain called cantaloupe terrain. Its surface is covered with ridges and pits that resemble the skin of a melon. Beneath its icy crust, there may be a global subsurface ocean. Radioactive decay in its rocky core, combined with tidal heating, may keep this ocean liquid. This environment could potentially support the chemical conditions necessary for life. Its average surface temperature is minus 235 degrees Celsius. It is one of the coldest places in the solar system. Yet it still has a thin nitrogen atmosphere. But this captured king from the Kuiper Belt has a tragic destiny. Its orbit is slowly decaying. About 3.6 billion years from now, it will cross Neptune's Roche limit. Tidal forces will tear it apart completely. The debris will form a ring system even more spectacular than Saturn's rings. Even today, humanity has only seen about 40% of Triton's surface. The remaining 60% is still completely unknown. At this point, you might ask, when will we return to Neptune? After NASA's proposed Triton mission was rejected in 2021, the most likely mission to Neptune may come from China. China has announced plans for a nuclear-powered Neptune exploration mission. It may launch around 2033 and arrive in the 2040s. Meanwhile, Voyager 2 continues traveling alone through deep space. It is now more than 20 billion kilometers from Earth, and Neptune still quietly orbits the Sun 4.5 billion kilometers away at the edge of the solar system. When you look up at the night sky, Neptune is there. Although it cannot be seen with the naked eye, it truly exists. It is a planet calculated by human intelligence, a world only briefly visited by a human spacecraft, and a distant destination that humanity will one day return to.